Building the workflow is the process of performing the various types of analysis you can do with Chromalyzer. One of those common things that we use the program for is to do comparison of one color file against another color file, or one palette against another palette. In order to do this, we would import the two sets of data and then start to look at that data in a variety of different ways. One method would be to send the color information into something we refer to as a view. Placing the view into the workflow, we can connect the first set of data by clicking on the output node, clicking on the input node of the view, and then by clicking into the view we can see in a three-dimensional screen the appearance of all of the colors that are in our first collection. By clicking on the output node and the input node of the second collection, we can now add in our second set of colorimetric data, and as we click on and off, we can see how that data appears and disappears in our screen display. Now clearly, if all of the data looks much the same, it's very difficult to see which is which. We resolve that in a couple of ways, one being to change the shape that the second set of color data appears in our 3D view. And so by setting the collection element to a square, we can now see those colors appearing as a square in our view. The size of the spheres and squares is also able to be set in Chromalyzer using this size tab, and these are done in measurements of delta E. So by setting this to 0.5, our spheres and squares are reduced in size relative to one another based on a space volume set by this LAB value. So if we increase it to 1, they get bigger, 1.5, they get bigger, and so this is essentially the area of color space occupied by a data point with a visual perimeter of 1 or 0.5 or whatever your setting is of that delta E. We can also choose the different equations by which that delta E measurement is, or that delta E space is represented. If we click on CMC, the CMC format gives greater weight to lightness and chromaticity in terms of visual difference, and a smaller difference in hue is perceived to be visible in CMC, or more visible in CMC color space. And so CIE D2000, CMC and LAB are the choices that we have for this relational display. Similarly, we can connect a filter into our view. Now, a filter allows us to take a more detailed look at this comparison. And so in the current view, this is all of the colors in a kind of 30,000 foot view to show where color palette A exists compared to color palette B. Here we can use a filter to reduce the overall size of the area that we're looking at. And so if we set our hue angle filter in here, we can either manually enter or use our sliders to select a space, a part of color space that we're going to review by sending the data from palette A into this filter, as well as the data from palette B into this filter, and then reconnecting that to a new view allows us to look at just that one slice through color space. This allows us to get a little bit more granular in our analysis, and so what we can see here in this segment is that color palette A has a significant strength in these bright colors. Each time we point to one of these dots, you can see which particular color we're talking about here and its colorimetric information. And then the squares represent this 144 palette. So here we can see that palette A is strong in the clean colors, palette B is stronger in the more neutral colors. And we can see what area, what overall section or part of this particular hue slice these two colors are occupying. Another function that we can build in here is a function which allows us to find colors which are either similar or dissimilar based on their colorimetric values. So once again, if we enter the data from palette A into one side of our function and from palette B into the other side of the function, and again we can have multiple palettes that can go into either side of this function. By using this Venn diagram we can specify the type of comparison. So using a delta E comparison of, we'll say 2.5 delta E, this is going to give us all of the colors from palette A and all of the colors from palette B that intersect at this point of similarity that we have defined as 2.5 delta E CMC. And so the resulting display shows us all of the colors from each palette which meet that criterion of similarity. And we can also send this information out to a report which can be imported into a Word document or into an Excel document. Similarly, we can find all of those colors in palette A which are dissimilar. So this selection says take everything which is outside or which does not have a similar color. We'll set this to 4 delta E. So this is telling us everything in this palette which is unique compared to everything in this palette. In other words, there is nothing in this palette that is within 4 delta E of our target palette. And so in this report, all of these circles are colors that do not exist in this 144 palette of color. Again, if we change this Venn diagram to the reverse, now everything in this palette that is unique compared to that is being displayed. If we want to combine the two, then here are all of the dissimilar colors. So using this tool we can very quickly and easily find similarities or uniqueness from each of those two color palettes.